Hello everyone, welcome to A plus BI. We're going to go ahead and solve this equation z squared equals 2i. There are basically two methods for solving this type of equation. The first method is going to be the polar form. So we can go ahead and actually write 2i as 2 times e to the power I times pi over 2. But you're also allowed to add a multiple of 2 pi, so that's going to be like 2 pi n. And then we can go ahead and square root both sides. That's going to give us the square root of 2. And then we're supposed to cut the angle in parentheses in half. So it's going to be e to the power I times pi over 4 plus pi n. You can replace n with 0 and n with 1, and that should give you the results. Let's go ahead and find out what those results are going to be like. For example, if n is equal to 0, we get z equals square root of 2 times e to the power I times pi over 4. As you know, I pi over 4, e to the power I pi over 4 is just going to give you cosine pi over 4 plus I pi sine pi over 4. So it's going to look like this. And then you can go ahead and multiply this by root 2, and that'll give you one of the roots. The other root is going to come from n equals 1, and that'll be pi plus pi over 4, which is 5 pi over 4, and that basically puts you in the third quadrant, so you're just going to have a minus sign. So we could put a plus minus sign there, and that'll do the trick. In other words, you can write this as plus minus 1 plus I, and if you have dealt with complex numbers before, you should know that 1 plus I squared is always 2i, and obviously there are two numbers whose square is 2i. One of them is 1 plus I, the other one is the opposite of 1 plus I, right? Okay, let's go ahead and take a look at the second method now. Let's go ahead and clean the board first, and then we'll look at the second method, okay? For the second method, we're going to do something different. Let's go ahead and call or set z equal to a plus bi. Because z is a complex number, and the name of this channel is a plus bi, right? You hopefully knew that. So when you square z, you're going to square a plus bi, and it's going to equal 2i. Let's go ahead and square the left-hand side. It's going to give us a squared, and then bi squared is b squared, I squared. But remember, I squared is equal to -1. So this is just going to be minus b squared. And then when you do the 2ab thing, it's just going to be 2abi. Very similar to 2ab with a slight difference. And that'll equal to 2i. Nice. Now we need to compare two complex numbers. How do we compare them? We can actually go ahead and look at the real parts and the imaginary parts. But the number on the right-hand side is imaginary. Some people call it just purely imaginary, which means the real part is 0. And of course, the coefficient of I is the imaginary part, which is 2. Great. We got a beautiful system from here. AB equals 1, right? And a squared equals b squared. Now, a squared equals b squared means that a is equal to b, or a is equal to minus b, right? So let's go ahead and write this down. From here, we get a equals plus minus b. And then from here, we do get the following. If a and b are equal, then from here we basically get a equals b equals 1, right? Or if a is the opposite of b, then what are we getting from here? We should get, actually it's impossible for a to be negative b, because the problem is if b is equal to negative a, and you plug it in here, you're going to get negative a squared equals 1, or a squared equals -1. But that's impossible because a is a real number. Remember that all the time. So what we have to do from here is only take a equals b as our valid solution. And if a is b, you can replace b with a. That gives you a squared equals 1. And that would give you 1, 1, and -1, -1. And that means that we have two solutions. And remember, we assume that z, or the square roots of 2i, would be in this form. So the z is either 1 plus I or -1 minus I. Just like in the first method, we got two solutions, and these two solutions are opposites. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.